Alright, this video is going to walk us through testing the significance of a linear correlation coefficient using using easycalculation.com. So this is if you don't have a TI-83 or 84. This is using the website instead. And so essentially what we're doing is we're trying to take a look at some data that we've collected from a population to determine whether or not there's a relationship. And if that relationship is significant enough to say that we can actually let it represent what we found from the population. So we start off by stating our null hypothesis. So our null hypothesis will be rho is equal to 0. And that simply means that there's no linear relationship. Recall that rho is the correlation coefficient. So what we're saying here is we're saying that our R value, our correlation coefficient, is 0, or very close to 0, which means that we have no relationship whatsoever. Our alternative hypothesis will be that rho is not equal to 0. So it doesn't matter whether rho would be -1 or towards -1, or whether it be towards +1. What we care about is that we find some type of linear relationship between X, the number of releases, and Y, the gross receipts. Now recall that as we're looking at these linear relationships, the correlation coefficient, that is, as we move from 0 closer to -1, recall that our relationship becomes stronger. And as we move from 0 towards +1, recall that our relationship grows stronger. Alright, so let's go ahead and move forward. Step 2. Step 2 is we need to establish a critical value. So remember, our whole idea here is that we have this normal distribution curve, and we want to establish a location or locations on our curve that would basically say that we created a critical region, a region that if we fell within that region, we could choose to reject our null hypothesis. So we start this guy off, and we know our sample is 1, 2, 3, 4, 5, 6, 7, 8, 9. So our sample size is equal to 9. Therefore, our degrees of freedom, which is equal to n minus 2, is equal to 9 minus 2, which is equal to 7. So I'm going to go with our main technique here is to use table F, and that's our t-distribution table, which you've used in previous situations. And in t-distribution, our degrees of freedom of 7, we would then scroll across at 7. We have a two-tailed test because we don't really care if it's in the negative side or in the positive tail. It's not greater than or less than. We just care that it's not 0. And so we scroll across, we have a significance level of 0.05. So two-tailed, 0.05. We come down and we see that they intersect each other at a critical value of positive or negative 2.365. Now, what I want you to correlate here together with this is I want you to understand at this point we could also have used the I table. And table I is basically a table that's been created algorithmically, so that way you can just go right from your correlation coefficient and compare this number off of it. Whereas this 2.37365, we're going to compare that with what we do with the t-test. Here, this guy, we'll just compare it with our R. So we'll do the same process. We have degrees of freedom of 7. We have a significance level of 0.05. So we have a test value of positive or negative 0.660. Okay, so recall, these numbers right here, these two guys right here are basically our critical values. Those are those numbers, those are our CVs, C dot V. Those are our numbers that establish this critical region here and critical region there. On this side it would be the negative, on this side it would be the positive version. Alright, so let's move forward to the next piece. The next piece is that we need to compute our correlation coefficient so we can kind of determine and we can test to see what's going to happen. So remember, this video is designed for us to use easycalculation.com. So I'm going to go and get that pulled up and so we can take a look and see how that looks. Alright, so here's what the website looks like. I provided the link for you here at the top of the presentation. It's as easy to define as basically going to easycalculation.com and then typing in correlation coefficient, and it pulls up in the link and so forth. But I've got it linked inside of the guided homework, and I have it linked inside this presentation, so you can just type in that web address right from there. Alright, so what you do is you come here and you type in 361, you can hit tab, go over, type in your Y, 344. You'll have to click on add more. You come down to that spot, you type in 270, tab, 1962. You gotta hit add more, and so then you come over here and sorry about that. And we type in 306, tab, 1371, and I'm going to hit pause. I'll finish putting my numbers in while you're putting your numbers in. Alright, so you get them all put in. Should be 9. It'll show right there. It actually is determining the correlation coefficient for me at this time. But go ahead and press calculate, and it kicks that guy out. So we can see that our correlation coefficient for this guy is going to be R equals 0.880. So I'll bring that back together in just a minute. Let's go ahead and find our t-test value at the same time. So our t-test value would be our correlation coefficient times the square root of 9 minus 2 divided by 1 minus 0.880 squared. Now, if you're using a TI-83 or 84, which if you are, then you probably just want to use the other video, but I'm going to demonstrate how to calculate this on the calculator. I like to just go ahead and plug it all in at one time if you have the right calculator. So 0.880 times second, see the square root right there? Then to get your fraction bar on this graphing calculator, you hit the alpha, then you hit F1. You choose number 1, and you type in 9 minus 2, that's 7, so we can just simplify that for us. And then 1 minus 0.80 quantity squared. Okay? Press enter, and we find out that our test value is 4.902. Okay, so let's just say you don't have the graphing calculator, and so you need to know how to plug this into a regular calculator. Well, my suggestion would be is you take care of what's inside the radical first. So go ahead and do this stuff first. Alright, so 9 minus 2 is 7, we can do it in our head, divided by, and then do open parentheses, 1 minus 0.880 quantity squared. Close the parentheses. So that number right there is what's inside the radical. If you can, go ahead and say second square root and type that whole entire number in there. The more you include in the number, the more accurate your final solution will be. If you start rounding too early, then what will happen is you'll get a number that's been rounded too soon, and you might be off by a hundredths or a thousandths. Okay? At this point, we've taken the square root of that number. So at this point, I've taken the square root, and I need to take the square root and multiply it times 0.88. So I say times, it brings down my previous answer, 0.880, press enter. And I get the same solution as I did before. Alright, so let's bring those test values over to my next page. So a couple things we have. We know that our R value is 0.880. We know that our t-test value is 4.902, and that's positive or negative. We go back to our previous page right here, and let's pull our critical values. I'll take a snapshot of that. It'll be just easy to pull it across. Okay, so now let's tie this all together. So we have our normal distribution curve again that we were looking at before, and we know a couple things. We know that this could either be this critical value right here could either be thought of as negative 0.666 or as positive 0.666. If that was the case, we would use our correlation coefficient. Our correlation coefficient is 0.880, excuse me, which means that I would be inside the critical region, which means I would reject the null hypothesis. Remember, and I pulled that information from table I. If you chose to use table F, then your critical value is, your critical value is this guy right here. So that'd be negative 2.365 and positive 2.365. Your test value would be 4.902. So 4.902 would be somewhere out in this area, And so therefore you would fall into a critical region, and therefore you would reject the null hypothesis. So, keeping that in mind, either way, whether you used, and this one, remember, this would be if you use table F. If you use the table F with the t-test, you're going to get a critical value. If you use table I with your correlation coefficient, you're going to get a critical value. The point is either one of those critical values established a test value that fell into a critical region, which then allowed us to say that there is a significant linear relationship between the x, which represents the number of releases, and the y's, which represents the gross receipts. So what we've established is, based upon this sample and its significance, we're able to make conclusions about the population because our responses were significant.